as Pasila mentioned, my name is Samuel Kihahu. Currently work as a DevOps engineer at a company called Tala. The reason why I chose the Red Cross, I think, is I see them doing a lot of good work, whether it's in Africa or in the Middle East, Europe. I think they are global, so I like the way they are able to address all the issues that are happening in the world that need attention. So as I mentioned, I work at a company called Tala. So Tala is a financial services company whose main mission is to provide financial access, choice, and control to the world's underserved populations. So these are the people who are not banked or are least banked. We currently work in 4 countries: Mexico, Philippines, India, and Kenya. And I am based in the Kenya office. So the DevOps team at Tala is distributed. We have a team in Nairobi, Kenya. We also have a team in Los Angeles, and also a team that's starting up in India. My talk today will be on testing infrastructure as code. Now, I think this has become one of the de facto ways of managing infrastructure. That is infrastructure as code, because it gives teams a lot of flexibility and visibility into what is being created or being provisioned. Teams are able to be able to review work that is being done by other teammates. So it basically makes the infrastructure very visible and makes it also possible for changes that are being made to be communicated earlier to the teams, and they're able to do sort of peer review of the code that is going out. So this is the agenda for my talk. Why test infrastructure? What tests to write? Where you can run these tests that you've written? What tools are available to you? And what lessons we've learned as we've been on this journey of testing our infrastructure. So my talk will be focused on some of the use cases or some of the examples or issues that we've run or lessons we've learned as we've done this at Tala. And it's in no way a fixed recommendation on this is how infrastructure should be tested, but it's just my take of the experiences that we've had at Tala as we've evolved our infrastructure from being created manually to eventually be doing the transition to having the infrastructure written as code and seeing the need to test it. So why test infrastructure? So first of all, one of the benefits that you get when you test your infrastructure is you're able to move with confidence, because you know for sure that every time your infrastructure is created, it's going to be created the same way every time. So you have that confidence that this infrastructure has been tested, and we know that it will come up this way. And this confidence is especially important when you're not the only one. And by the only one, I mean the DevOps team. You're not the only one relying on that infrastructure, but say you have other teams that depend on the infrastructure. So at Tala, we classify our infrastructure as core and non-core. So by core, I mean this is strictly managed by the DevOps team, but then we have the non-core infrastructure that we give developers leeway in creating and sort of managing. And when I mean confidence by other teams, this is what I'm referring to, the non-core infrastructure, which will be used by other teams, and they need to be sure that when they call, let's say, a Terraform module that creates an SQS queue, it will actually create an SQS queue that is named this way and has these particular attributes. So another benefit of testing infrastructure is because of the confidence, you're able to move now with speed, because you know you are highly aware of issues that you've faced in the past, and you're able to anticipate them. Because you've written your tests, you're able to move because these potential issues that are likely to come up have been addressed by the test cases that you have. So speed is another benefit that you gain when you write tests for your infrastructure. Another benefit you get when you write the tests is feedback. So one common thing that we've encountered at Tala is if we find it hard to write a test case for a certain implementation, then it means our implementation is probably overcomplicated or overcomplex and might need to be refactored. So that tests will give you that kind of feedback. You're able to validate your implementation of your logic. Another benefit of testing infrastructure is when you write your test, it can sort of serve as a documentation for your infrastructure code. So this is actually one thing I've come to have as a gotcha whenever I'm exploring new projects and new software. One of the ways that I'm easily able to pick up and understand how the project is working or it's structured is by looking at the tests that have been written for that particular project. So the tests that you write serve as a good onboarding tool for somebody else who come and work on that code base. So finally, I put testing helps you be able to easily experiment with new features. So you're able to play around with some new architecture configurations or new features. An example being maybe you want to explore migrating your application to run on Kubernetes or be multi-cloud. It's easier for you to do this when you have tests as opposed to when you're to doing it without any tests at all. So now let's look at what kind of tests we can write. So one kind of test that we can use, and I think that's pretty common for most people, is static analysis. So this is where you have your IDE configured or some linter configured within your IDE as a plugin to check whether it's for the style of the language that you're working on, or whether it's for grammatical errors. And it's usually pretty fast and quick, and it doesn't have any time implication, so it's easy to run, and you actually get the feedback very fast as you're doing your as you're going along writing your code. The other kind of test that you can write is unit tests. So unit test would help you test a specific component within your infrastructure. So I mentioned at Tala we have this non-core infrastructure that we write modules for, and then we have developers inherit those modules and create their own resources. Example being an SQS queue. So you can be able to write a unit test specifically to validate that actually that SQS queue, that resource gets created. And they are not dependencies that you're testing. You're just verifying that whether it's Terraform code or TerraGrant code, it's actually going to create that resource and return to you maybe a resource name or a resource ARN if you're working on the AWS cloud infrastructure. The other test you can do is integration test. So in this kind of test, you're more or less combining two or more unit tests that are dependent on one another. So an example I can give is you're writing an SQS queue that also depends on having an IAM role being created so that it can be able to access certain features, or it can have the access it requires. So that would be an example of an integration test. So you're testing two components that are dependent on one another. Another kind of test that you can write is end-to-end tests. So by end-to-end test, this is where you want to bring all the infrastructure pieces that you've written and tested, whether you using unit test or integration test. You bring them all together, and you also have from the service endpoint, you have test traffic being routed to this infrastructure that you've brought up. So in this kind of test, you probably have to now work with other teams like the quality assurance team to ensure that the infrastructure that you're bringing up actually is able to have the uptime that you want, or it's able to serve the application services or the services that you are working on. Other tests that you can put or you can have is these are tests for when you're in production. So an example is the blue-green deployments. You can have this canary deployments, rolling deployments. So the point is, you're actually now using an actual production environment and feeding not test data but production data, and using that to evaluate how your application is able to fare with this traffic. But the key thing that would differentiate it from my last point there of monitoring in production is that you're just sending a segregated amount of traffic. You're not sending all the traffic to the blue-green or canary deployment, but just a specific segment. And based on the feedback that you're getting, you continue rolling out your traffic and eventually have all the traffic being served by infrastructure that you've provisioned recently or with the recent changes. And as I mentioned, there's also finally the monitoring in production, and this is where you've set up performance metrics that you're using to gain visibility into how your infrastructure is faring. So these are some of the tests that you can have to validate whether your infrastructure is actually working as expected. So now we ask ourselves, where can we run these tests? So for static analysis, unit tests, and integration tests, some integration tests, it's actually possible to run these tests on localhost. Remember when I mentioned about static analysis, one of the things or one of the features about this is they're pretty fast and you get the feedback instantly. And they are actually also very, very visible because you see them on the whichever IDE you're working on. So it's possible to do this on localhost. Unit tests are also possible to test on localhost because you're just testing one individual component and verifying that it is actually working as expected. Integration tests, some of them are possible to test on localhost, but there are some that you can't. So when I talk about some of the tools that you can use to do your testing, I'll explain about that division of possibility of testing on localhost and some not being possible to test on localhost. But one of the features that stands out from testing on localhost is you're able to do this very fast because you're doing it on a machine that is local to you. There's no latency. You don't have to have requests going to the cloud and coming back to your machine. So it's pretty fast because of the low latencies. And also the cost, because you're not provisioning any resources on a commercial cloud provider, the cost is minimal. So the downside for doing this localhost will probably be the fact that there might be resource intensive, especially if the number of tests that you're running are many. So your machine becomes a bottleneck on the kind of, or how fast the tests can be done. Moving on, we have integration tests, end-to-end tests. There's the blue-green deployments and the monitoring in production. So these can be tested on a production-like environment. So the reason why I gave it production-like is because people give this environment many names: dev, QA, stage, non-prod. But the whole idea is it's an environment that mimics your production environment. So that is the main point, that it's close, it's very close, or actually a mirror of your production environment. And these are the tests that you can run to validate that your infrastructure that you're writing, whether it's your Terraform code, your Helm chart, whenever it's deployed in an environment that looks like your production, and the resources come up as expected without any errors, and any interdependencies for the resources actually are created. So another thing that you can do in this, you're able to run simulated tests. So whether you have load tests to validate that in this production-like environment, you're able to trigger a high load test and validate that your application is able to do things like scale up, alert if certain thresholds are met. So this is what you can do with this is what you can do in this production-like environment. And finally, there's nothing that replaces production. Eventually, everything gets to production, so we still need to consider deploying or testing in production. And this is where the blue-green deployments, the canary deployments, the rolling updates come into play, where you're actually using a production environment but that is segregated, and using gradual changes, or rolling out gradual changes, and validating that the changes that are going out are not breaking any of your services. And once you have the full confidence in the changes that you're rolling out, you can fully shift your production traffic to the new infrastructure that you've set up. So monitoring is key in this testing in production, because it gives you a lot of visibility into the uptime errors that you're getting, and you're able to roll back if you have issues that you identify based on the performance metrics that you've set up. So after looking at where we can run the traffic, I'd like to talk to you about some of the tools that we're using at Tala to do this testing. So a key tool for us has been terratest. So terratest is an open source testing library based on Go, or written in Go, that has been released by a company called TerraGrant. And one of the reasons why we chose to use terratest is the fact that it's open source. So we're able to, if you have issues, it's possible to raise issues on GitHub and get community feedback. You're also able to get changes or updates fairly fast without any cost implications. Previously, we'd used a tool called TerraGrant by the same organization, Grant work. So TerraGrant is a wrapper around Terraform that adds more features to what Terraform can do. So our experience using TerraGrant was very positive, and we were confident in using terratest to use for our testing of our infrastructure. Another key reason why we chose terratest was its support for a lot of the DevOps tooling around out there. So you find that it has support for, as I mentioned, Terraform, TerraGrant, Kubernetes, Helm, Docker, Packer. The list is endless. In fact, if I was to give it a name, I would say it's the Swiss Army knife for testing that I've encountered so far, because it covers a lot of tools in the DevOps SRE space. So we also leverage Kubernetes like tools or emulator tools for testing on local hosts. So an example is Kind, which stands for Kubernetes in Docker. You also have Minikube and K3s. So for us, we use Kind. Our experience has been Kind is pretty fast to come up, and by design, it's been created to be used as a CI testing tool. It's actually used by some of the Kubernetes SIGs for testing their work that they're doing. So Kind has been really good for us. So Minikube, our experience has been it takes time to come up, and it's pretty resource intensive. For K3s is a Kubernetes distribution designed for edge computing, and it's by Rancher. But you find, and it's pretty small. The footprint is very small, and it comes up very fast. But they've been able to achieve that fast boot time by stripping off alpha and beta features and experimental features. So it's kind of limited in what you can test with. We also use local cloud emulators to simulate environment. So a Tala environment is set up on AWS. So localstack has been a key local cloud emulator for us. But there's also Google GCP also has a limited set of their services available on emulators. I think I saw they have Bigtable, Spanner, PubSub, and cloud storage. I've seen Azure has abstractions, but this is not something I've played around with as an emulator that you can use to test on localhost. Then finally, there's the actual cloud. As I said, for production testing, there's nothing that will replace actual production infrastructure. And for us, we still need to test in the cloud. So I'm going to talk to you here about how to write the terratest and some of the features that it offers that allow it to be flexible in making you or in helping you write your tests for the cloud. I mean, for your infrastructure. So as I mentioned, terratest is built on top of the Go language. So it inherits a lot of the Go testing patterns. So an example being that the test that you're writing needs to end with _test.go. You're able to run tests in parallel. When you write your tests, the function name needs to start with capital test, and then it has to follow this naming format. So capital test, and then the name of the test that you're writing. And then it has to be after the test, the first letter needs to be capitalized so that it's exported and available when you're running the tests. One key feature that we found very useful is the fact that terratest supports tags. So by tags, I mean it's possible for you to write tests for various pieces or components of your infrastructure. So you can write tests for Helm, tests for Terraform, tests for raw Kubernetes deployments, and you're able to tag these tests accordingly. And based on the tests, you can be able to, if you look at my example that I have here, you're able to pass a flag for tags, and you can be able to limit the tests that you run. So when you are running your tests, you can decide what tests you're able to, or what tests you want to target to run, instead of running everything and having it consume a lot of resources if you're testing locally, or have your tests take a long time because you are running on the cloud and you are running everything, an end-to-end test that will bring up the whole of your infrastructure. So you're able to surgically decide what resources you want to test. So the other feature that we find really useful is it comes with a lot of function or helpers that will help you be able to simulate various kind of tasks. If you look at my example here, you find that one of the things it comes with is a random unique generator. So when you create your resources, you want them to be created or named uniquely, so that if somebody else is running tests at the same time, whether on localhost or on the cloud, that there is no name conflicts. It's also possible to, or another thing that we find really good about terratest is the fact that you're able to, once you create your resources and you validate that it created the resources that you wanted, you're able to destroy those resources after the tests have gone through. And this is important basically for cleanup and cost maintenance, because you're able to reduce your costs and don't have to worry about somebody running tests and leaving resources idle in the cloud, which would have a cost implication for you. So those are some of the features that terratest has. As I mentioned, it's an open source project, and I think I have a link at the end of this presentation to the repo. So this is an example of how you'd configure your local emulators so that you're able to run your tests. So the first at the top here I have, so these are Terraform. As I mentioned, we use Terraform and TerraGrant a lot of how you'd configure the Google provider with a custom endpoint that is pointing to a local instance of, for in this example, this is Spanner. And then in this second example, I have the AWS provider, and I've configured it to point to the SNS and SQS local instances that I have provided. These are provided by localstack. So one of the things that you notice about Terraform is it's possible to create these custom endpoints that allow you to test on localhost. Another thing is it's possible to have provider aliases. By provider aliases, I mean you can have multiple providers defined here. So you can have provider Google that has a custom endpoint, and then you can have a provider Google that actually points to the GCP cloud. Or if you're using AWS, you can have provider AWS that is pointing to the local instances of your emulators, and then have provider AWS that is pointing to the actual AWS cloud APIs. And by having these various kind of aliases, you're able to do hybrid testing. So you can switch between testing on locally on your machine and testing on the cloud. So one notice or gotcha about the emulators, the custom endpoints, is you find these Terraform providers only provide best effort support. So if there's a new feature that comes up, in localstack. Before it gets supported on the upstream Terraform providers, it might be a while, or it might take time before it gets supported. So an example I have is a point they did a refactor and made it possible, instead of having individual ports for each of the services. So for SNS having 4575, SQS having 4576, they've introduced one service that allows you to access all the resources. So it's not been supported yet, although I've seen an issue created, and one of the things I've noticed is from the feedback they've mentioned that you can actually change these ports to be the port of that edge service, and your service or your pointing to SNS on localhost should be able to go through without any issue. So that's just something to be aware of when you choose to test locally. The tests or the support for the emulators are not supported instantly. So finally, I would like to, as I conclude, I'd like to share some of the lessons that we've learned as we've been using these tools and testing our infrastructure. So one of the lessons is to choose your testing environment based on the function of the infrastructure. So I mentioned you can do localhost, production-like, and production. And I mentioned at Tala we have core and non-core. So for non-core, it's been possible to do for the DevOps team as they create the modules that will be used by the developers. Localhost testing has been sufficient because you're just testing the individual component. But eventually, when the developer uses the module that you've written in creating their resource, in the CI that that resource will be created, that test will be done on an end-to-end test in an actual production-like environment. So here you have to kind of weigh what kind of test are you writing, and what is the function of the infrastructure that you're writing for. Cost is also a factor. So that's the reason why for DevOps team, as they create resources for other developers to use, it makes sense to test locally. But then when the developers use those modules that have been created by the DevOps team, we find it's better to have that whole flow tested on an actual end-to-end test in a production-like environment. So consider the cost also. Cost also in terms of time. So for DevOps team, it makes sense to move easily on your local host because you don't have any dependencies on other teams. You're writing a module that will eventually be used by other developers. So you can easily move fast when you're doing the tests locally. But when the developer is using the module written by the DevOps team, the implication is there's an end user service that will use that resource, and although cost is a factor, the experience for our user is higher than the cost. So we prefer to have the developer resource being tested on an actual cloud environment. Another thing to consider we've learned is about CI integration. As you write more and more tests, as I mentioned, tags become a key feature because you're able to choose between what kind of tests you want to run and what kind of tests you want to leave based on the environment that you're testing in. So we also use Makefiles a lot to help us easily integrate into our CI tools. One of the things we've also realized is busy monorepos. So an example is a repository that has modules that are inherited by developers. You find that there will be a lot of, if you make changes and you want to test the individual components, you'll have a lot of PR triggered that would also trigger CI jobs to run. So one of the ways we've controlled this is to have Git hooks, whereby the DevOps team would write their module and then write a test for that module and then have it run as a Git hook. Instead of having the test triggered on the CI job on GitHub, the test is triggered from their local host, and they're able to test that it is actually working. Another reason is also on the security. You find that a DevOps team have more privileges than normal developers. So they're able to do testing, more deeper testing when they use Git hooks, and they don't expose the credentials that they have or the privileges that they have, as opposed to having this on a CI pipeline where you'd have to create secrets on whether it's Jenkins or Circle CI or whatever CI tool that you're using. So CI integration is also something that you would also want to look at. So as I mentioned, we also we use cloud emulators, and for us, local stack, since we're using AWS. But these emulators also have their limitation. So like local stack has a specific set of services that are available as open source, and then others are paid for. So when you're using the emulator, the service that you're testing needs to be on the list that is available as open source. Otherwise, you have to use the paid version of local stack. For GCP, I saw the services that they have with emulators are pretty limited. I think I only saw four services: Spanner, Bigtable, Cloud Storage, and PubSub. So that can be limiting if you want to test something locally and it is not within that list of supported emulators. In terms of the terratest library, some of the lessons have been it defaults to timing out at 10 minutes. So if you have tests that will take longer, you need to change the default timeout. In terms of error handling, you find that terratest gives you a combination of, I mentioned it's very rich in terms of the functions that it gives you. So these functions come in the form of functions that handle errors or return errors, and functions that just handle the errors for you. So when you're writing your tests, you need to decide whether you want to use the functions that handle the errors for you, or the functions that will return the error for you, and you have the code you write the code to handle the error for you. So I'll show you this when I'm doing my demo. I mentioned also about the unique naming of resources. So if two or more people are running resources in a cloud environment, to avoid name collision, it's better to name your resources uniquely. So finally, is about caching. So you find if by default caching is enabled, so if you run a test multiple times, you are likely to get a result that is from a previous test, because Go caches the result. So you can turn off caching by passing on this flag. So at this point, I would like to switch to my terminal window and show you a quick demo of some of the tests that I have as samples. So I'm going to share my terminal window. I hope you can see my terminal.
Yeah, I can see it.
Okay. So the setup that I have is I have localstack running on this window. So the tests that I'll be showing are just running on localhost. I'm not going to be running on the cloud, just to show you that it's actually possible to run on the local host. So I have localstack running here to emulate AWS, and I have one of the GCP services, Spanner, running as an emulator. And then in this window, I have a Kubernetes cluster running in kind, and I'm listing the pods that are created in all the namespaces. And in this window, I'm watching for all the services that are created. So I'm going to show you an example of a test that I'll write. So first of all, this is my makefile. So I'm using a makefile to make it easier for me to run tests for the various environments that I have. So as I mentioned, with terratest, you're able to tag your tests. So I have tagged SQS tests, SNS tests, Helm, Kubernetes, and GCP. Then I've also tagged GCP and SQS and SNS tests as Terraform tests. And I also have AWS test and GCP test. So the reason I'm showing you this is just to show you the flexibility of tagging. So if I want to run Terraform tests, it's going to include all the GCP and AWS tests that I have. And if I run these Kubernetes tests, going to run Kubernetes and Helm tests. So you are easily able to pick and choose the kind of test that you want. So, or if you want to test an individual resource, you can choose, say, test SQS alone. So I'm going to, or maybe let me just walk you through an example test. So this is an example Helm test. So this is the tag for Helm and Cube. So when I do the tags, I'm able to filter by these tags. And then, so I mentioned you're using terratest on top of the resources that you're creating. So here I'm pointing to this path where my Helm example is. So it's actually just basically a Helm chart. So if I go to Helm and you look at so it basically has a deployment and a service. A deployment and a service. But the power now of terratest is I'm able to supplement or provide, say, input from my terratest test that I'm writing. So an example is the namespace that I want the resource to run into. I can be able to create a namespace that is random using the random this random method. I'm also able to provide things like have I think a random port. So the examples that I'm running here, I'm using the node port service for Kubernetes, but it's actually possible to use an ingress controller like Nginx because it's supported. But I'm using a node port. So for my use case here, I need to get a random port on the localhost machine that I have that is not in use by any other service, and use this to create a tunnel and expose that, so that when the test runs, it's able to actually get the service that has been deployed and do a HTTP check to validate that I get a status 200. If I get any other status, my test will fail. If I just take one of the examples for AWS resources, you see I've tagged it Terraform, AWS, and SNS. And similar to the Helm test, I'm able to create random naming I'm able to use terratest's AWS library to create or simulate an AWS region. I'm able to pass options to this options struct and giving. So I give the path where my Terraform code resides. I'll show you that in a bit. But I'm also able to pass variables. So if when I go to the SNS code, I have a name variable, and this is being passed now from terratest. I'm also able to pass things like environment variables. So when I can pass a region that I get from this AWS library. And this is what I was mentioning about being able to clean up. You're able to, since you're doing a defer, this will run at the end of once the test is finished, but we are sure that the resources will be destroyed once I'm done with creating my resources, and I don't have to worry about going and doing the cleanup manually or worrying that somebody will leave their resources running and have to incur some cost because they remain running in the cloud. So if you worked with Terraform, you know you need to do an init and then do an apply. Then your resources are created. And then Terraform gives you an output of what is created. So in this particular case, I'm able to get the output, which is the ARN for the SNS that is created. And I'm able to actually assert that the ARN matches the ARN that I expect. So I'm able to compare and validate that the naming of the ARN will actually be as I expect. So this is the SNS code. So this is where I declare my provider, and then I have the simple SNS. I just actually use the open source SNS module, and I have this name. So this name is the one that is now being supplied by terratest. So I'm going to switch to my terminal and run a few of the tests. So I'm going to just start with SQS. So if I do make SQS, so this is running against my local stack environment. And you can see it's running, and it's created the resource, and it shows you the outputs here. This is the queue that was created and the ID for it. And after it created and validated that the resources were created, it will destroy this. So this is what you expect when you run this test in an actual cloud environment. So I'm going to run the Kubernetes tests. These ones I expect them to initiate a simple Nginx deployment, create an Nginx deployment and an Nginx service, and validate that service has come up, and then do HTTP call and make sure that I get a 200 to ensure that the service actually came up and was created as expected. So as I mentioned, I'm using the Q-ball. So this Q-ball means it's running not only the Helm test, but also the raw Kubernetes deployment. And in my two windows here, you can see the resources getting created. Yeah, so it created the resources, did the test to get the 200, and once it got the 200, it has destroyed the resources. So I can see my resources or my pods being cleaned up once the test has been successful. So I'm going to switch back to my presentation. So just a recap of what I talked about. just to give you something to remember, that you can test locally and it's cost effective, it's fast and convenient, and you're able to build confidence because you're not afraid of breaking a cloud environment out there, but you know you're testing locally. But then there are limitations, as we saw with localstack and the cloud emulators for GCP. They don't support all the services. For localstack, you have to pay for some of the services. For GCP, not all the services are supported. So local testing might has a limitation. So you can take a hybrid approach where you take advantage of the benefits of testing locally, and then once you are done testing locally, you can switch and test in the cloud. And then production-like testing is ultimately important because your service or your infrastructure will be serving actual traffic in the cloud. You need to have an actual test environment in the cloud and the provider you are using so that you're able to validate your infrastructure works as expected. So some of the references, these are great talk. I mentioned that terratest, TerraGrant are open source tools by a company called Grantwork. So they have a really good talk about testing. I'd recommend you take a look at it also. I have a link to Terraform, how you can configure various aliases for the providers, which would allow you to do the hybrid testing. There's also a documentation on how you can do the configuration for configuring the local emulators. I have a repo also that has the tests that I was showing you in my demo. This is the link to those examples. You can have a look at them at your own convenience later on. And then this finally, I have a Google Terraform provider documentation that also shows you how to configure the emulators for localhost testing. Yeah, so thank you all for listening to my talk. I enjoyed the remaining part of the conference.
Thank you, Samuel, for that eye-opening talk. It's interesting to see infrastructure being in the image and likeness of dev. So we have some questions in the stage chat that you can answer via chat as we take a 6 minutes break to be back at 10 past the hour. So we are breaking for 6 minutes and then we'll do our closing keynotes. See you in 6 minutes.